Hi, it's Dr. Khan with chapter 6.5 to 6.7. We're going to be talking about the three different types of volcanoes, the three main types of volcanoes: shield volcanoes, cinder cones, and composite volcanoes. For each, I want you to be able to associate the kind of volcano with the type of magma and where it's likely to be formed. Shield volcanoes, imagine a shield like Captain America's shield. If we lie that down on the ground, it would just be a very gently sloping, broad shield, and that's actually what our shield volcanoes look like. They're the largest of the volcanoes in terms of the size of the base. They're broad, slightly dome-shaped, and they're made out of basaltic lava. That should tell us a couple of things right off the bat. Basaltic lava forms from the melting of the upper mantle, but we don't mix in any continental crust, meaning it's probably occurring in the ocean. These are mild eruptions, not really violent. When they build up enough solidified lava over time, they become taller and taller and taller as they grow from the floor of the ocean. And maybe if the eruptions continue, they might even break through the surface and become a volcanic island. For each of these types of volcanoes, there's a really great smart figure that I think gives a good visual, and it will also, by watching these, it'll help you successfully complete your labs as well. So I recommend either pausing the video now in between each one, or after watching this lecture, going through and watching each of the smart figures that represent the different types of volcanoes. Cinder cones are the smallest of the volcanoes, and they often occur in groups. It's also basaltic lava, interestingly, and sometimes these would just pop up kind of over the course of weeks and months. There's a famous set of these cinder cones that appeared, I believe, in the 1960s in Mexico or in a farmer's field, and really relatively quickly appeared where there was no volcanic activity that was evident before. Again, another smart figure that gives that indication of, or a little more information about cinder cones. But I want you to, again, remember that it's the basaltic lava flow. What actually makes these steep slopes on the side of the cinder cones are actually fragments of basaltic lava that are ejected and cool, and then collect and form these steep sides. Composite volcanoes are the largest of the volcanoes. This is what someone would draw if you asked them to draw a picture of a volcano. They're thousands of feet high and very wide at the base, although not as wide as our shield volcanoes. And if we could slice the volcano in half and kind of look at what it was composed of, we would see alternating bands or layers of lava, and then ashing and dust and kind of debris, rocks, and then another layer of lava, and then another layer of that pyroclastic debris. So we would see it almost like a layered cake of events that indicate multiple flows. These eruptions are the most violent of the eruptions, and we tend to find these in areas where part of the crust, the continental crust, is being melted. So we're adding in felsic compositional magma. We end up maybe with something intermediate, but there's more silica involved than there was for basaltic lava. So we have a lot of gas. We have viscous magma that's blocking that gas from easily escaping. And as that magma rises with all that volatile materials, the water that wants to turn into gas, it's going to expand in size and essentially can blow the side off the mountain, because that pressure will build and build and build, and it can't be released. That pressure really cannot be relieved because that gas is expanding and can't get out of that very viscous material. If you think about it like trying to blow bubbles in honey, if you blow bubbles in water, remember that was like our basaltic magma, it's very easy for those bubbles to reach the surface and break the surface. But if you try to blow a bubble in honey, you're probably going to lift up that whole surface of the honey, and it would be very difficult to break through. And again, that's what's happening with our gases and in our magma. They want to expand as they form gases from a liquid state and kind of get trapped and have nowhere to go. Here's our classic composite volcano, beautiful volcano. But when you put the three profiles next to each other of our three different types of volcanoes, it's very interesting to see the difference in scale because, going back here for a second, our composite volcano, this looks like a very large volcano, and it is, but really just pales in comparison with the size of the shield volcano that makes up Mauna Loa, Hawaii. That's this whole volcano here versus our composite cone, Mount Rainier, that's in the Cascades, just like Mount St. Helens, and our cinder cone in Arizona, the smallest of the three types. And that is it for this section.